Hai semua, dalam video kali ini saya nak tunjukkan macam mana nak cari Bnet pada yang menggabungkan antara dua wire yang mempunyai bentuk yang berbeza. Alright, so kita tengok sini. Figure 1 shows a vertical straight wire inside a horizontal single loop. The radius of the loop is 12 cm and the wire is 4 cm. So, this is the wire and this is the loop. Okay, and then dia kata the current in the wire is 8 ampere. And the current in the loop is 5 ampere. And then dia kata determine the magnitude and direction for the resultant magnetic field at the center of the loop. So dekat sini. Alright. So what is the first thing that we have to do is we have to draw vector diagram. So untuk vector diagram, kita kena cari B wire dulu. So B wire. Wire tadi kita nampakkan dia naik ke atas kan? Then this one. So kita kena guna right hand grip rule. So sini wire saya dan sini saya akan jadi saya punya magnetic field. Alright. So wire saya macam gini. Lepas tu saya punya magnetic field macam gini. Tapi disebabkan titik ni tadi dekat center of the loop tadi dekat sini kan? Maka bila saya guna pusing, dia masuk ke dalam. So, masuk ke dalam. Tapi saya tak nak duka macam ni. Kali ni, dia boleh lagi satu. Okay, kita tengok dulu. Okay, so kita ada loop kita. Loop kita dia macam gini tau. So, bila kita guna right hand grip rule, kita masih guna kaedah macam ni. Tapi kali ni, yang jari saya yang ni, yang berpusing ni, yang ini akan jadi saya punya current. Dan ini pula akan jadi saya punya B. Dia boleh tukar ganti, okay? Ini boleh jadi saya punya current, sini boleh jadi B, atau sini boleh jadi current, sini boleh jadi B, magnetic field. It depends pada jenis bentuk wire tu, okay? Dia boleh tukar-tukar ganti. So, wire current saya tadi gerak macam ni kan? Tengok pada soalan ni. Current tu gerak macam tu. So, current saya boleh gerak macam ni. So, saya punya magnetic field pergi ke atas. So, ini B wire. Yang ini pula ialah B loop. B loop naik ke atas. So, macam ni kita tak faham kan? So, saya tukar balik semula dia dalam bentuk paksi. When I change it to, this is paksi Y, this is paksi X, and this one is paksi Z. So, saya nampak B wire, B loop naik ke atas. And then, saya punya B wire masuk ke dalam paksi Z. Okay, it goes into, so this is BW, right? So now that we have here, we can see that they are not in the same plane. So what we have to do, we have to resolve. So before we go to the resolving method, we have to find the magnitude for BW and the BL. So BW equals to mu naught. Sebab ikan B wire is a straight wire, right? So kita kena guna BW equals to mu naught I over 2 pi R. And since we are dealing with two types of magnetic field and magnetic field calculation, we have to show the difference between BW and BL. So this one is WI, this one is IW and RW, and this one is mu naught I. For the loop, the equation for the loop is 2R. So this one is IL, and this the R is RL for loop. Right. So we have to list down all the information first. Let's see berapa banyak kali first tak tahulah ya. Sorry. So IW tadi untuk the wire. Let's see from the question. We can see for the wire is 8 ampere and 8 ampere. And the I for the loop is 5 ampere. There, 5 ampere. And then the R for W, look at this. Mana tak clear pula. Alright, there you go. So we can see here, this is the radius for the wire. We can see this is 12 cm. So ada sama kan? This one is the radius of the loop. This is 12 cm. And the distance here is 4 cm. We are trying to find this radius. So what we have to do is, So RW is 12 centimeter minus dengan 4 centimeter. So we get 8 centimeter, right? So which is equivalent to 0.08 meter. We have to show this one. Okay, we can just assume we have to show every single step that we do in our calculation. We have to show. So the RL is definitely 12 centimeter, right? Alright, now let's continue with the rest of it. Okay, so mu naught is 4 pi times 10 to the power of negative 7. And then the IW just now, you see, when you list down all the information, it will be very easy once you want to do the substitution. So 8 divided by 2 pi, RW is 0.08. So the answer is 2.0 times 10 to the power of negative 5 Tesla, and the direction is into the page. Yes, and next we are doing this one. So 4 pi times 10 to the power of negative 7 times dengan IL kita ialah 5 ampere, sorry. So 5 ampere, 5, and then 2 kali radius kita RL is 12. So 0.12. So the answer should be 2.62 times 10 to the power of negative 5 Tesla, and it goes upwards. Alright, since now that we have all the two magnitude, then we can do resolving. Why do we have to do resolving? Because they are not in the same plane, right? So yes, let's do, where is it? Okay, so the Bnet equals to cert BW squared plus BL squared. Okay, and then equals to, we just do the substitution. BW is 2.0 times 10 to the power of negative 5 squared plus 2.62 times 10 to the power of negative 5 squared. And you can get the answer 3.296 times 10 to the power of negative 5 Tesla, but we don't know the direction. We have to find it. Alright, so the tangent theta equals to this one, paksi y per paksi z. Okay, so BL over BW equals, okay, so the answer should sama. Tak nak buat macam ni lah, sorry lah saya punya tulisan macam gini, because I want to do it fast, so you don't have to, so you don't have to view it boringly. So the answer is above z axis. So that's how we do the direction for this question. So we have to do the magnetic field. Just remember, so the Bnet, if the Bnet is in different axes, you have to make sure you have to do some resolving. If the question, if you do the vector diagram like this, vector diagram, for example, BL and then BW, one goes in and then the other one goes out, then it will be very easy for you. You just add in BL minus BW, you see, because they are in different direction, right? So you can just simply do substitution or addition based on the vector diagram like this, because they are in the same plane. But for this one, they are in different planes. So for different planes, again, sebabkan B magnetic field ialah vector quantity, so different planes require vectorizing. And for like this, same plane, you can just do addition or subtraction. Alright, thank you.